Hello everyone, we are discussing pure inductor with an alternating source, and so far we have developed concept of V and I and phase difference. This is the inductor. E is E naught sine omega t, and I is I naught cos of, let me write down the sine version, the correct phase difference part first. Sine of omega t minus 90. This I naught is the peak current and its value is E naught divided by XL. And what is XL? XL is reactance offered by the inductor, which is omega L. This is something which we did in the previous class, and then I had asked you to plot a graph between V and T and that between I and T. And only a few tried this thing, but none of you got it correct. But at least you're better than those who did not even try the whole thing. E is E naught sine omega t, I is I naught sine omega t minus 90. When I say what is VL, VL is potential difference across the ends of the inductor. So what is this potential difference across the ends of the inductor? I hope you remember, it is E only. And what is E? E naught sine omega t. So when I say you need to plot a graph of V versus T, you're simply plotting a graph of sine omega t. So those of you who got it wrong, V versus T for sine. What is the shape of sine? This is the shape of sine. Same thing we did with pure resistor, same thing we did with pure capacitor, and we're supposed to draw the same thing for VL also. This is the graph of sine. Now, draw these partitions. And you know that these partitions are at T by 4, T by 2, 3T by 4, and so on. T by 4, T by 2, 3T by 4, and capital T. This is the peak value, which is for this particular case E naught, but you can always write as VL naught. In this case, VL, its maximum value is what? Maximum value of E, which is E naught. Right now you can write this VL naught as E naught. This is minus of VL naught. What is the difference between VL and VL naught? VL is instantaneous value of potential difference across this inductor. And when I use naught, it gives you what? Maximum value. So, this is what is known, and then you need to plot a graph of sine omega t minus 9t. What is this? This is, in fact, this minus of I naught cos omega t. In fact, if you remember from this, only we arrived at this relation. First we got this, and then we converted this part into this part. I hope you remember that. So, you are supposed to plot a graph of cos with a negative sign. Over here, I am drawing I versus t, which is the graph of cos. Graph of cos starts from this. What is cos 0? 1. So this is minus of cos. So your graph starts from this position. Right here. And then it takes this shape. This is the shape of minus of cos. When sine is maximum, sine 90 is 1, you know that cos becomes what? 0. I hope you remember at least this much. So that's how you can relate cos and sine. This is minus of cos. This place is minus of I naught. This place is plus of I naught. Same partitions. Partitions means when time is t by 4, current is 0. When time is t by 2, current in the circuit is maximum. When time is 3t by 4, current becomes 0. When time is capital T, current is minus of I naught. Draw this thing. Now, let me give you the reason behind this phase difference, and you can understand that with the help of this graph very easily. Meaning of phase difference. If you look at this portion right here, when time is t by 2, current is almost constant. The top portion, it looks like this. So let's focus between this and this over here. For this portion, you can say that I is almost constant. You cannot say this for this region. Over here you can see that current is increasing very rapidly. But right here, current has become almost what? Constant. A flat portion. So, if you say that for this region, I is almost same if I is same, then flux associated with the inductor Li, that is also same. So if phi is same, then Faraday says induced EMF will be 0, and therefore VL, potential difference in the inductor, right over here is what? 0. So current is maximum, but potential difference is 0. One of the oscillator is at the mean position and the other one is at the amplitude. This is called a phase difference of pi by 2. And why does it happen? I explained this thing with the help of this small part. So if somebody is interested, they can they can draw this part separately, mention that I is almost same and therefore flux is same, and therefore induced EMF, which is potential difference across the inductor, is 0. That tells us why we have a phase difference of 90 degrees. And you can also understand this way, the second part also. Right here, I is 0 over here, but it is changing very rapidly. From negative region, you're moving into the positive region. So change in I takes place at a very fast rate. So if change takes place at a very fast rate, then what is induced EMF? L di by dt. So change is very fast and therefore you're getting a very big value of potential difference. Although I is 0, but it changes very rapidly. And therefore it is giving us VL maximum. Again, this tells us the meaning of 90 degree phase difference. Note down this. And write down the statement also. Just draw the graph, the side portion. In the graph of I versus t, at t by 2, current is almost saturated. Saturated means it is same. It is no longer increasing. At T by 2, current is almost saturated, and therefore di by dt is 0. Di by dt, small t, di by dt is 0. And because of that, VL is 0. And because of that, VL is 0. Similarly, at time t by 4, capital T by 4. Similarly, at time t by 4, current is 0, but it is changing very rapidly. But it is changing very rapidly. Inside the bracket, from negative, it becomes positive. From negative, it becomes positive. And therefore, rate of change of current, di by dt, small t, rate of change of current di by dt is maximum. And that's the reason we see maximum value of VL. And that's the reason we see maximum value of VL. And this thing explains the meaning of, phase difference of 90 degrees. Now write down LCR circuit. So far we are discussing pure resistor, pure capacitor, pure inductor. Now let's see when all three are present. This is the most generalized case. Everything is present. L, C and R. Everything is present in an alternating circuit. So this is your E equals to E naught sine omega t. Inductor L, it will offer a resistance of XL. Remember this. Capacitor C, and it will offer a resistance of XC. A resistor R, and you know that it will offer a resistance R only. So this is L, this is C, this is R. Now tell me this, let me see what your understanding level is. When you connect LCR like this in series combination, then in which component L, C or R current will be maximum? If you can answer, then write down this in the comment box. Which component L, C or R will have maximum value of current? Good. All three are in series, and therefore they all will have what? Same current all the time. If current in this is 5 amperes, then that very moment current in this will also be what? 5 amperes. Current in this will also be what? 5 amperes. They are in series, and therefore every time you look at this circuit, current will be same. Although current, its direction changes, but if I say that current at a given moment is I and is flowing in this direction, then current in this will also be I, flowing in the same direction. Current in this will also be I, flowing in the same direction. Right on this point, as all three components L, C and R are in series, current will be same. Current, and make it more precise term, write down the more precise term. Instantaneous value of current. What is I? Instantaneous. Instantaneous value of current will be same in all three. So as I said, when this has a current of 5, this will also have 5, this will also have 5. At some other time you found that current is flowing in this direction, and that is 2 amperes. Then at that very moment, this will also have a 2 ampere current in this direction, and this will also have the same current of 2 amperes in this direction, because they all are in series. Now, we have no idea what this I is. So we have no idea. We took I as what? I naught sine omega t plus phi. The way we handle this circuit is this technique. We are interested in finding I. We have the source EMF. So we know that whatever current is flowing, it has the alternating form. And what is the alternating form? Some peak value, a function of sine, which changes with time and has a additional phase part. What I am saying is this: when we had only R, these two were not present. When only R was present, this I naught was E naught divided by R. I hope you remember. Let me see if you remember or not. What was phi when these two were not present and only R was present? What was the value of phi then? Write down in the comment box first. Only 2-3 people are trying to answer. Rest, as always, they are struggling. They are struggling because they have not revised anything. So again, it's a humble request. Whenever I teach you something, if I am teaching you alternating current, then it's your responsibility that before I start my class, you should go through everything we did in this chapter. Brief, in half an hour you can do that kind of revision, and if you do that, you can answer questions like these. So when L and C were not present, only R was present, this phi was 0. The shape was only of this type. There was an I naught, which was E naught divided by R, sine omega t plus 0, and we used to say that phase difference between potential difference across the ends of resistor and current flowing through the resistor is 0. Let me ask you again, when L is not present, R is not present, only C is present, then what's the value of phi? Write down fast. If this is not present, this is not present, only this is present, then what was the value of phi? Good. It was 90 degrees. Or pi by 2. And if this and this are not present, only this is present, this is something which we did in this lecture only. So when only L is present, this phi is what? Minus of 90 degrees, minus of pi by 2. This gives us an idea that if all three are present, let's take an unknown in the form of phi. With phi you represent phase. This is not flux this time. This phi is giving you phase like 0, 90, minus 90. And there will be some peak value. And our aim is to find what? I naught and phi. This is what we are interested in. We need to find these two things. So these are the two unknowns for us. If we can find this and this, we know everything about an LCR circuit. Now, let's see how we can handle this. What is I? I told you I is instantaneous value. What is I? Instantaneous value. Instantaneous means at time t, current is I. This will keep on changing. Similarly, potential difference across this inductor is VL, across the capacitor is VC, across the resistor is VR. So these are what instantaneous values of potential differences across these three elements, VL, VC and VR. Look here with R first. If I ask you what is VR, look carefully. This VR will have a certain peak value, maximum, which was given by VR naught. Term of sine and then something inside. Who will tell me what should I write over here inside the bracket? Instantaneous value of potential difference across the ends of the resistor is found to be VR, which has a certain maximum, which is VR naught, sine, and then I need to write something. The hint is, you have this. Let's see who can answer this part. What should I write over here? You've got 30 seconds time. Let me see if you can answer this part. It's taking too long. Now, many a times people write sine omega t. That's all. This is sine omega t and therefore they also write sine omega t. But no. Try to remember the statement which we had for pure resistors. The statement with pure resistors was phase of current and phase of potential difference is same for a resistor. And you just answered this a while back when I asked you what's the value of phi if you have only R present, and then you answered that phi is what? 0. So phi 0 means what? If you have a resistor and it is present in any alternating circuit, then potential difference, if you measure it and its phase and current flowing through it, then we find that they are in same phase. Same phase means when current is 0, potential difference is 0. When current is maximum, potential difference is maximum. Which means this VR and the current I, they are of same phase. What is VR? Potential difference. What is I? Current flowing through it. And we know that they are always in same phase. So what is the phase of I? This is the phase of I, the whole thing. Inside sine, the whole part is called what? Phase. Phase of? That means this is omega t plus phi. Phase of potential difference and phase of current, they are same. Those of you who understand this part that it should be omega t plus phi, write down yes in the comment box. And then let's go for VC. So this VC, you can write at some other place. I'm just writing over here so that you can easily relate. VC will have a certain maximum value. Let's call it VC naught, not for the max. Similar to this, VR naught, VC naught, E naught, I naught, and then sine something. I have told you this. I gave you the reasoning behind this. Now write down in the comment box what should appear over here. For phi, you can simply write PHI. Simply write PH for phi. For omega, you can use W. T you know. Or you can save time. For phi, you can simply write P also. That will give me an idea. Not a single correct answer. Think about it. I'm giving you another 30 seconds with the hint. What was the statement with capacitors? For capacitors, we used to say that a phase difference of 90 exists between current and potential difference. If you see I and if you see VC, a phase difference of 90 is present between these two, such that I leads in phase by 90 degrees. This is the hint. If you wish, you can write this hint also. With this, write down the reason for this omega t plus phi. And maybe this will help you in finding this value. When a resistor is present in an alternating circuit, the phase of current and phase of potential difference are same. Phase of current and phase of potential difference both are same. This statement is for omega t plus phi. Now, I told you that when a capacitor is present, then for a capacitor, current leads the potential difference. Current leads. That means this is something which is leading this VC. How do you lead? In this form. That's how you complete this part. So if I say that I leads by 90 degree. If I leads by 90, that means V lags behind by 90 degree. And that's what is happening. If you have the value of V, if you know the phase of V, then add 90 and you will get what? Phase of I. Right here, we have the phase of I, and therefore we are subtracting 90, which gives us VC. If you understand this, then write down yes in the comment box, and then find out what should I write over here. If I go for VL, it has a certain maximum value, and then something should come over here. Write down this in the comment box in terms of omega t. Use W for omega. For phi, you can use simply P. Good. But first write down the reason behind this, the way you wrote the reason for this. For this minus 90, write down the reason. When a capacitor is present in an alternating circuit, and this is also the revision, you can expect questions in this form. When a capacitor is present in an alternating circuit, current leads potential difference by 90 degrees. Or we can say that potential difference lags behind by 90 degrees. Lags behind by 90 degrees. And everybody has answered correctly. Over here we'll be using omega t plus phi plus 90. This is something we did in today's class. Remember, in today's class what we found? We had found minus 90 when we were discussing inductor. But what was that minus 90? For inductors, current is something which lags behind. So if somebody has given you the phase of VL and he asks you the phase of I, then you will say that phase lags behind. And you will subtract 90. But if somebody has given you the I, phase of I, then definitely potential differences which is going to lead by 90. Write down the statement for this also. We are again and again doing same thing, which is a revision part, because this is something which is asked most from alternating circuit, concept of phase. So if you have any confusion, feel free, you can switch on the mic and you can ask me anything you like. Write down the statement. When an inductor is present in an alternating circuit, current lags behind which means we can say that potential difference leads by 90 degrees. Potential difference leads phase of current by 90 degrees. Now just mention a point so that no confusion remains. VL, VC, VR, these are what? Instantaneous values. So write down VL, VC and VR are instantaneous values. Instantaneous means at time t. Whereas VL naught, VC naught and VR naught are the peak values, maximum values, peak value. Now, what is VR? I'll help you in this, and then you have to figure out for L and C. What is VR? Potential difference. What is the maximum value of that? What do you know? Ohm's law. Current flowing through the resistor is what? I, which has a maximum value of I naught. And what is resistance? R. So it tells you that this VR naught is I naught multiplied by R. That's your VR naught. This is simply what? Potential difference. What is potential difference? Current multiplied by resistance. What is the current? I. But we are looking for maximum. So go for maximum value of current, which is I naught. So this is VR naught, Now get me VL naught. Write down VL naught and write down VC naught. In the comment box. Too much. What is VL naught? I naught into L. Is it correct? Yes or no? VL naught, just like VR naught, I naught into R. Can I say VL naught is I naught into L? Yes or no? Good. At least you answered this much. We cannot use I naught into L. What is used? I naught multiplied by resistance. Resistance offered by the inductor. What is that? XL. So simply use XL. And this time this is correct. So what is VL naught? I naught multiplied by XL. I naught multiplied by resistance offered by the inductor. And similarly, VC naught is I naught multiplied by resistance offered by the capacitor, which is called reactance of the capacitor and is XC. Now, what is the relationship between VL, VC and VR? This will be asked as an objective question and therefore write down this as a question. What is the relationship between VL, VC and VR? Relationship between VL, VC and VR. What is VL? Instantaneous value. What is VC? Instantaneous value. What is VR? Instantaneous value. Look here. I'm giving you the hint. The hint is this. This is a hint. Do you remember we used to draw a circle and then we used to put an arrow? What does it stand for? If you can figure out what does it stand for, then you can easily answer my question. This this thing, this blue part, if you can see the color blue, this whole thing stands for Kirchhoff's second law. In a closed loop is, what is the Kirchhoff's second law? Sum of potential differences is what? Zero. So any type of circuit you have, DC, AC, or a mix of AC, DC, Kirchhoff's law is always valid. So what does it tell us? It tells us that VL, VC and VR, sum of these three will be equal to what? E. This is the source. Its instantaneous value is E. Its instantaneous value is VL, instantaneous VC, instantaneous R. Then sum of these three will be equal to E. Right on, from Kirchhoff's second law, draw this first. Instantaneous value, instantaneous, instantaneous, instantaneous. From Kirchhoff's second law, VL plus VC plus VR is equal to what? E. VL plus VC plus VR is equal to what? E. An important result. Now, just remember these things, everything. And I'm erasing this part. And before I do that, let's use a shortcut, for representation purpose. Let's call this omega t plus phi. Let's call it theta. It will save us a lot of time. This is theta. So this is theta, then this will be VL naught sine of theta plus 90, which is VL naught cos theta. So instead of using this whole part, we can write VL naught cos theta. Not a big thing. We are saying omega t plus phi is theta, then this is sine of 90 plus theta, which is what? Cos theta. And using same logic, we can write this. I hope you can figure out yourself. Let me write the whole thing fast. It will be VC naught cos theta. This is theta. So it becomes what? Sine theta minus 90. Take the negative sign out. So what is inside? Sine 90 minus theta. What is that? Cos theta. Simple maths. And if you find this is difficult, don't worry. After the class you can ask me. So do we handle this? But as of now, I'll assume that this is a very easy part. So why did we convert this in this form? Let's put these values in this. Let me put the values and then I will remove all this. This is also done. Look, what is VL? VL naught. VL naught. What is VL naught? Cos theta. This is your VL. What is VC? Minus of VC naught. What is VC naught? Minus of I naught x c cos theta plus VR. What is VR? VR naught, which is this I naught into R sine of theta, and this whole thing is equal to what? E. What is E? E naught sine omega t. This is the end of physics. Now we have to solve this equation. If we can solve this, we can find these values. So physics has found this relationship for you. And how do we handle this? Just note down this much and then I'll teach you how to handle this also. So this is the advantage of taking this omega t plus phi as theta. Now remember this omega t plus phi, we have taken this as what? Theta. We'll need this part later on. Now I will do mathematical part fast. This is something which you are taught in 11th class. What is this? This is, first of all, take I naught common. Once I take I naught common, I've got R sine theta then plus XL minus XC cos theta. Cos theta common, XL minus XC. Which is equal to E naught sine omega t. This. Now, I hope you remember something like this. If I have got y, which is a sine theta plus b cos theta. Those who have taken bio, even they must have seen this thing when they were taught vectors and all. If you have not, look here fast. This whole thing is root over a square plus b square sine of theta plus alpha. You must have seen this thing in simple harmonic motion. You must have seen these type of things in waves in 11th, in vectors also. you multiply and divide by this and you get the form of sine A cos B plus cos A sine B, which is this root A square plus B square sine theta plus alpha. This part you construct a triangle, right angle triangle with this angle alpha, this length B and this length A. This part becomes root over A square plus B square, AB right angle triangle. Then what we have done, what is cos alpha in this? So if I divide this A with root A square plus B square, then I will get cos alpha. I'm being fast, just remember this in case somebody is interested. What is cos alpha? A divided by root A square plus B square. If you divide this by root A square plus B square, it gives you cos alpha, sin theta cos alpha. If you divide B with root A square plus B square term, then this gives you sin alpha cos theta. So you got sin alpha cos theta plus cos alpha sin theta, which is this. Go down this fast, this part, take a screenshot or whatever you wish. We can write this whole thing into this form where we have a right angle triangle like this, and this right angle triangle is giving us this information that tan of alpha is B divided by A. Do this fast. Now, look here. This whole setup is of the same type. You can consider R as A. You can consider XL minus XC as B. So this is like A sin theta plus B cos theta. A sin theta plus B cos theta. Which means the right hand side, the left hand side, it is like this. I naught. Keep it out. What is this? Root A square plus B square. Root over R square plus XL minus XC whole square. A square plus B square. Sine of theta plus alpha. What is alpha? Tan alpha is B upon A. What is B? Coefficient of cos. What is A? Coefficient of sine. And this part is equal to what? E naught sine omega t. This is the mathematical part. Physics is already over. So this becomes this with the help of this much maths. Now, left hand side is equal to right hand side. This is the term of sine, this is the term of sine. You have a coefficient over here, you have a coefficient over here, and the whole thing is equal. How do you justify this? Like this. I naught multiplied by R square plus XL minus XC whole square. This whole thing, if is equal to E naught, and theta plus alpha is equal to omega t. If you say this is this and theta plus alpha is omega t, that means you are saying LHS is equal to RHS. And that is the solution part. Last few minutes, look here. Look here, just 2 minutes more. This whole thing under the root, it is called Z, impedance. We'll discuss these things in the next class. This whole thing has a name Z. What is Z? Impedance. What is impedance? We'll discuss that in the next class. Right now, then theta. What is theta? Omega t plus phi plus alpha is omega t. Theta. Omega t cancel. Our aim is to find what? Phi. Phi is coming minus of alpha. Shift. Phi is coming minus of alpha. If phi is minus of alpha, then what is tan phi? Tan phi is tan of minus alpha. What is tan of minus alpha? Tan of minus alpha is minus of tan alpha. Tan phi, tan minus alpha, which is minus tan alpha. But what is tan alpha? Coefficient of cos, coefficient of sine. If you remember, coefficient of cos was XL minus XC and coefficient of sine was R. Just over here, that was the part. Take the negative sign inside. If you take the negative sign inside, it gives you tan phi, this, XC minus XL divided by R. This is your tan phi. We are interested in finding phi. We have found its value. We are interested in finding I naught. We have found value of I naught as E naught divided by Z. What is Z? This whole part. Everything is known. So we have found everything for LCR circuit. Now how does it help us? We'll see that in the next class. Hopefully you understand this much maths. If you do not, just don't worry. Remember these two results. Note down this much and then you can leave. Thank you very much.